All right, this is CS50, and this is lecture 1. And you'll recall, of course, that just a few days ago we introduced programming and some fundamentals of computing and computational thinking, so to speak. And today we're going to build on those ideas, but begin to transition to a more cryptic-looking, but nonetheless much more powerful language, transitioning ultimately from Scratch. So odds are by now you had an opportunity with Problem Set 0 to experiment with Scratch and drag and drop puzzle pieces. And recall that the real point of Scratch, beyond having a bit of fun and showing off what you can do with something like that, is to explore ideas like loops and functions and conditions, maybe some Boolean expressions or events. It really depends on how you pulled those ingredients together. But today we introduce a language that's been around for quite a while longer, decades, called C. And it's an older language, and frankly, after CS50, odds are you're not likely to use this language all that much, if ever, but it's been a foundation for a lot of the more modern languages that have come. And so roughly mid-semester, when we transition to another language, Python, and then thereafter SQL, and then thereafter JavaScript, you'll see a lot of those same origins and syntax and ideas. And indeed, everything we did last week in Scratch, you're going to see permeates all of these various languages. Because at the end of the day, you're not learning C in CS50. You're not learning Scratch or Python or JavaScript. You're learning the fundamentals of computer science and ultimately the tool of programming. So today, let's begin to translate some of last time's ideas into more cryptic looking, but nonetheless fundamentally identical ideas as follows. So this was a super simple program that simply displayed on the screen out of the mouth of a cat, by default, hello world. Well, let's begin to translate this to something textual, as most programming languages actually are, by first focusing on just this block. This purple puzzle piece we called an example of what kind of programming construct? Yeah, it was like a function, a verb, or an action, do something. In Scratch or MIT decided to make them purple, but that was just arbitrary. But they're consistent in the program because they're all very similar in spirit. Now in C, starting today and for several weeks hereafter, that same purple puzzle piece is going to start to look like this. And we saw a glimpse of this last time, printf, hello world. But notice there's a few salient characteristics beyond just the words hello world. There's printf, and we'll see what the F stands for today. There's a parenthesis and a closed parenthesis over here. And that kind of balance is going to be important, not intellectually, but just syntactically, because the computer is going to expect you to be super precise. The quote and unquote, we'll see, surround words that you write in a program. So whereas last time in Scratch, you simply typed a word in a white box, now you're going to do the same thing on your keyboard, but surrounding it with quotes. And then lastly, there's going to be this nuisance, this semicolon, which a lot of languages have, which simply says end of thought. It's like the programmer's equivalent of a period in an English sentence. And you'll find that among the frustrations that new programmers experience, myself included back in the day, is you don't really notice these things from the get-go. And you might type out all of your logic and feel good about your program, try to run it, and the thing doesn't work because of something stupid like you forgot this. So the key takeaway for today especially is don't get frustrated by the stupid stuff. You're absolutely going to bump against walls, not quite seeing what someone like I might see after all these years of practice. But in just a few weeks' time, you'll start to notice patterns. And the mistakes you might make in the first week are going to be much more obvious to you in the second and third and beyond. So this then would be a function in C. Let's combine it as a complete program, which you did see a glimpse of last time. So if you were to implement this same program, hello world in C, these are the several lines you would have to type. You can't just type printf. You have to sort of set up the program. Now, why is that? Well, we can tease this apart by looking at just a few of the keywords in this example here. So highlighted now in yellow is main. And some humans, years ago, just decided, you know what? When another human is writing a program, he or she has just got to call their function, as we'll soon see, main. They could have called it anything they want, but main is kind of a nice word for the main part of your program. So this is the equivalent of our when green flag clicked in the language called C. Meanwhile, if we highlight another keyword, printf, this is going to be the C equivalent of the say block in purple. So printf is just going to print something on the screen. Meanwhile, in yellow here now is what we're going to start calling a string. A string is just a technical word for sequence of characters, or words, phrases, paragraphs, whatever it is. So that is a string highlighted now in yellow. And notice that it's sort of being supplied, as we'll see, to printf. It's immediately coming after the word printf, just like hello world in the white box immediately came after the word say. And now things get a little more arcane. Now highlighted in yellow is stdio.h. Definitely the most cryptic of the keywords so far. This happens to stand for standard input and output. And that's just a fancy way of saying this file, as we'll soon see, is somehow related to printing, and somehow related to, which is output, and somehow related to keyboards, which is input. So somewhere in that file we'll see is the sort of functionality that you would hope a computer would have, outputting stuff and taking input. And so we'll see that that's where we get that kind of standard functionality. Scratch does not have an equivalent. It just all kind of works, which is nice in Scratch. Meanwhile, this keyword include, we're going to see, is literally just saying that. Hey, hey computer, please include standard input and output functionality so that I actually do something interesting with my program. And without that line of code, you couldn't do as much in this language C. Now let's look quickly at a few other puzzle pieces, a few concepts that intuitively are probably pretty straightforward, and then we'll transition partway through today to actually writing code and lots of actual examples and running the code as well. But last time you might have implemented an infinite loop, one that just goes forever, with a forever block. And in Scratch, you would then have a say block or something else on the inside. Starting today, that same puzzle piece is going to look a little weird. It's going to look like this. While true, printf hello world. And frankly, there's a bunch of different ways you could implement this. I'm just sort of choosing the simplest, relatively speaking, or most canonical. But why is this the same? Well, I've highlighted in yellow the first line, while true. And while is kind of a nice word in English insofar as it just kind of intuitively suggests like while something is happening. That's kind of loop-like. And meanwhile, in parentheses, this is a Boolean expression. Scratch had these by dragging and dropping those puzzle pieces on the equivalent block when you had conditions. But in this case here, we're just saying while true. So true. True is like yes. And the other day we said yes is kind of like the number 1, whereas no is like false or the number 0. And that's great because if we have a true-false world or a yes-no world or a 1-0 world, that wonderfully maps to the hardware we all have in our laps and in our pockets, which is a computer based on transistors and electricity and all that we're going to now abstract away from. Don't care how electricity works today. I don't care about 1s and 0s. All I just know is that I can represent 1s or 0s, 1s or 0s. Or equivalently true. So while this lamp is on, or while this lamp is true, printf hello world. So the reason logically that the code you have on the screen there prints hello world forever is because it's as though we've never turned the light bulb off. It's just while it's on. Keep doing this, doing this, doing this, doing this again and again and again, just like in Scratch. Meanwhile, we might also do the following after a number of iterations of that. We might have a finite number of iterations with this repeat block. This one says, of course, repeat the following 50 times. Now this one is going to look a little uglier for sure. This is probably the most conventional way to translate this Scratch block to C. Now it looks like a lot all at once, but again, after a couple of days, couple of weeks, you'll start to see the patterns. Let me highlight some of the features of this code. So highlighted in yellow here is what we're just going to call an initialization. This says, hey computer, give me a variable, call it I, just because I could have called it anything, and initialize it to 0. So again, just like in algebra, you might have x equals 0 or y equals 0. This is just I equals 0. And even though we haven't talked about this, you might be able to guess, what does this keyword int perhaps mean? Integer. That's right. I mean, we didn't have this same idea in Scratch. In Scratch, if you want a number, you just type it. If you want a word, you just type it. But in C, you have to be a little more uptight. You have to actually tell the computer what type of value you're putting in your variables. They're not just going to be numbers, integers. Turns out we can put strings. We can put trues and falses. We can put other things as well down the road. So this is just saying, hey, computer, give me a variable that's going to store an integer, a number, like -1, 0, 1, and so forth. But initialize it to 0. Make it the number 0 by default. And that's it. Succinct, if cryptic way of saying it. Then this block of code says the following. Hey, computer, just to be safe, is I less than 50? That's a Boolean expression, true or false. So is I less than 50 at this moment in time? Yeah, obviously, because it's 0. That's, of course, less than 50. So the computer then does the following. Printf hello world. So it initializes the variable. It checks that it is less than a certain number, 50 in this case. And then if that condition is true, it proceeds to print hello world. And even if you've never seen code before, perhaps by process of elimination, what step is probably going to come next? What am I next probably going to highlight on the screen? Yeah, the I++. Not obvious what it does quite yet, but you can perhaps guess. I++ is a conventional way in this language to just say, you know what, go ahead and change i's value by 1. So if 0 becomes 1, 1's going to become 2, 2's going to become 3, and so forth. But for now, we're just changing 0 to 1. So at this point in the story, I is 1. What does the computer do? Now it just kind of repeats things bunches of times. It's going to check again, hey, is I less than 50? Simple question. I is 1, so is I less than 50 now? Yeah, obviously so. And so it's going to print hello world again. Then it's going to increment I, so now it's 2. It's going to double check that condition. Is 2 less than 50? Obviously, yes. And then it's going to print hello world. It's then going to increment, which is going to become 3. It's going to double check that condition. Is 3 less than 50? Obviously. And then it's going to print hello world. And it's going to continue that process. Take a guess how many times? 50 in total. Because eventually, and we won't bore ourselves with the whole story, eventually I is going to equal 50 because of a whole bunch of pluses. And at that point in the story, the computer's going to ask the question, is 50 less than 50? No, obviously not. And at that point, the code stops executing. And whatever is below it in your program, like lower in your file, that's what's going to happen next, even though there's nothing pictured there. So again, cryptic, but it follows this pattern. And once you sort of get comfortable with that pattern, you're going to be able to bang this out on a keyboard and just know what it's supposed to do without even having to think about it so methodically. Now, the other day, this was perhaps the biggest set of puzzle pieces we played with in person, even though it's probably just a small piece of some of your own Scratch projects now. But it actually maps pretty nicely to C code. It's not colorful in the same way, but you'll see that the other day when we asked is x less than y, in code, it actually looks pretty identical. In fact, it might be a little simpler to look at. We just have some parentheses. We have the less than sign. And of course, x and y, which in this context are assumed to be variables, like x and y in algebra. Where do they come from? I have no idea. In this context, we're just assuming this is part of a bigger program. So if x is less than y, print out x is less than y. Else, if x is greater than y, print out x is greater than y. Else, print x is equal to y. And so just like these yellow puzzle pieces kind of are embracing the purple puzzle pieces, similarly do you have these curly braces, which maybe you have never actually had occasion to use on your keyboard, but odds are they're there, probably around your Enter key on a US keyboard. These are like sort of wrapping the lines of code that you want to actually execute. Now, there's a curiosity I haven't called out just yet, and we'll come back to this. This weird \n. We'll see why that is there in just a moment. So let me pause for just a moment, because that was already a mouthful. Any questions on functions or on loops or on conditions as we begin to translate them from Scratch to C? Anything at all? Yeah? Good question. Why are there 2 plus signs and not just 1? If you have just 1 plus sign, and we'll actually see this in a bit in an example, that literally means add 1 number on the left to 1 number on the right. So in this case, it's just because is kind of the trite answer. It's because if we want to have this special operation where there is no number on the right, you're just adding 1 to the number on the left. Humans years ago just decided plus plus is pretty succinct, and it's not used for other purposes yet. So that's all. Yeah? Yeah, right there. Correct. I wouldn't start thinking about it as having a loop inside of it, because we'll eventually see that you can literally put another for loop, as it's called, with the keyword for, inside of another by indenting it inside. So think of, when you're looking at a for loop, like the one we just saw a moment ago, think of the loop as really being all 4 of these lines. And like something is just kind of happening cyclically around the whole body of that code, so to speak. Other questions? Yeah? Why do we use int for the main method? Let me take the fifth on that for just a moment. What you're alluding to, just to be clear, is this example here, whereby in our most canonical, sort of simplest, relatively speaking, but program that does the least amount of work possible, we also mentioned int here. We also mentioned this curiosity here, void. Let me just defer that answer for a little bit until we have the vocabulary with which to answer that.